Good afternoon, friends. Today we're going to start talking about Unit 12, sequences and series, and today our focus is going to be on arithmetic, sequences, and series. All right, so a sequence is arithmetic when the difference between the consecutive terms are the same. So arithmetic sequences tend to be more linear. They have a common difference. So if we have the terms a sub 1, a sub 2, and this here represents the first term, this here represents the second term, a sub 3 is the third term, so on and so forth. It's arithmetic when there is a number d such that d is constant. Okay, so d is constant. And you can almost think of d as slope. All right. So if we want to compare this to something we already know, you can think of d as slope. However, a sequence is really a list of terms. So instead of connecting and having just a continuous graph, we're actually just going to have a series of numbers. So d is actually called the common difference. And we have two formulas. So these formulas actually do the same thing. A sub n, which actually represents the nth term in your sequence, is the first term. So a sub 1 is the first term plus n minus 1 times d. Or we can do this as a sub n equals dn plus c, where c is really kind of like a sub 0. So if we think of that in terms of linear, it's really kind of like the y-intercept. All right, so let's apply this. Once we get going, I think you'll find that it looks familiar and it's not so bad. All right, so number one, it says tell whether the sequence is arithmetic. If so, find the common difference. So if I'm looking at the list of numbers 2, 5, 8, 11, and 14, I'm asking myself, do they have a common difference? Is there something that I can add or subtract to each term and come up with a pattern? So if I look, the difference between these two numbers is 3. 8 minus 5 is 3. 11 minus 8 is 3. And 14 minus 11 is also 3. So that tells me that I have a common difference of 3. So this is an arithmetic sequence, a list of numbers that has a common difference. If I look at the second problem, if I take 4 minus 8, I get negative 4. If I take 2 minus 4, I get negative 2. So right here, there is no common difference. So because there is no common difference, I can look at this list of numbers, this sequence, and I can tell that it is not arithmetic. Okay, so example 2, write the first 5 terms in the arithmetic sequence a sub 1 equals 6 and d is 1/2. So if I think of this, I have the first term, I really want the second term, I want the third term, I want the fourth term, I want the fifth term, and I want the sixth term. And we won't always write it like this, but I want you to get into the habit of knowing that a sub n is really representing the nth term of the list. So a sub 2, if I have the number 6 and the common difference is 1/2, that means for my next term, I'm going to subtract 1/2. So if I take 6 and I subtract 1/2, my next term is going to be 5/2. 5, oh, actually, I totally went the wrong way. I don't know why I'm subtracting. Let's erase that and start over. Okay, rewind. If I have 6 and my common difference is 1/2, I'm taking 6 and I'm adding 1/2, so my next term is 6/2. If I keep adding 1/2, 6/2 plus 1/2 is 7. 7 plus 1/2 is 7/2. Keep going, add 1/2, add 1/2, and add 1/2. If I think about what that graph looks like, I can only graph what I know. So if I come over here to my graph and I think about labeling my graph, the horizontal axis is representing n, and the vertical axis is actually now representing our 8th term. we have to remember a sequence is a list of numbers. So I have the first term, I have the second term, I have the third term. I don't have the 1.2nd term and the 2.5th term. Okay, so this is going to basically be a series of dots, not connected, and that's the hardest part because we're so used to connecting these. Okay, it's going to be a series of dots on our graph that are not connected. So our first term is 6, so I can come over here to 1, and I can go up to 6. Our first term is 6. Our second term is 6.5. Third term is 7. 7.5. Keep going. 8. 8.5. And you could keep going after that if you wanted to. The seventh term would be 9. And at this point, you're done. Do not connect the dots. Like, you literally have to hold your hand back. I get that, but don't connect them because the sequence represents a list of numbers. All right, so we don't always have the first term, so sometimes we kind of have to work backwards and see what we know. So I have the 8th term and I have the 12th term, and I know that I have a common difference. So I know that when I have a arithmetic series, I know that I have a common difference, which is kind of like, all right, this is going to be linear. So if I think about what I know on this back end, I know my 8th term, I don't know my 9th term, I don't know my 10th term, I don't know my 11th term, but I know my 12th term. My 12th term is 8, my 8th term is 20. And I know that I am decreasing at a constant rate. So if I take the difference between 8 and 12, or 8 and 20, I get 12. And if I take half of that, I get 6. So I know that if I take 20 and subtract 6, I get 14. And if I take 14 and subtract 6, I'm going to get 8. So it's kind of like I just averaged 20 and 8. You could have done 20 plus 8 divided by 2, and that's going to give you 14. If I keep going and I look for the 9th term, I'm looking for the term that's halfway between 20 and 14, so that difference is 6. And if I cut that in half, it's 3, so this is 17. And 14 minus 3 is 11. So when I look at this pattern of numbers right now, I can tell that this pattern of numbers is decreasing. So I know that D is going to be -3. I could also start at 20 and I could go backwards. So if I want my first, second, third, fourth, fifth, sixth, seventh, my 8th term is 20. So if I need the first 5 terms, I could go backwards. 20 minus 3 is 17. Nope, I need to go forward, so I need to add 3 because I'm going the opposite direction. So 20 plus 3 is going to give me 23. Keep adding 3 because I'm going the opposite direction. This would not be my favorite way to do this. However, 35, 38. However, what's going to happen is I'm going to eventually show you how to do this using the formula, and it's a little bit easier, I think. But sometimes people think following a pattern is easy, so it's really whatever you want to do. And again, if I'm going to graph this, this is n. This represents a sub n. So my first term, and I am going to label these 10, 20, 30, 40, so I can get all the way to 41. My first term is 41. My next term is 38, and I'm going to keep going down 3, down 3, down 3, down 3, down 3. So for every unit you go over, you're essentially going down 3. So this is the 5th term, this is the 10th term, and graphically, if you wanted to kind of keep your pattern alive so you could check it against the initial numbers, we could do that. So my 12th term was 8. So if you look here, here's your 12th term, and this represents 8. And again, I know you literally have to hold your hand back, but do not connect those points. A sequence is a list of numbers. All right, so let's write a rule for the nth term of each sequence. So if you look back at your formulas, you have 2 formulas. I'm going to use the one that says a sub n equals dn plus c, where c equals a sub 1 minus d. And this is really basically like C is going to be a sub 0. So if you kind of think of that in terms of linear functions, that's kind of like your y-intercept. So if you think of what's happening here, our first term is 100. So when we're at our first term, we're at 100. And our difference is minus 8. So we know that this is going to go down, down, down. So that means our first term was right here. So our a sub 0 in this problem was 108. So if I write a rule for the nth term is going to be my common difference, and I'm just using this formula right here. It's my common difference, which is negative 8, times n plus my 0th term, and my 0th term, or C in this problem, is 108. So this is basically my general formula. So what does this mean? This means if I wanted to find the 10th term, I could find a sub 10, and I could come in here and I could plug in negative 8, and n is 10 because I'm finding the 10th term, plus 108, negative 80 plus 108, so a sub 10 is 28. So this really means the 10th term is 28. All right, so moving on, write a rule for the nth term of the sequence. So what I want you to think about, this is similar to an example that we did earlier. We have my first term, we have my fourth term. So I need to find my common difference. And difference is kind of like slope. So I could take 5 minus 15 over 1 minus 4. And if I do that, 5 minus 15 is negative 10. 1 minus 4 is negative 3. So my common difference is 10/3. So I have my first term. So I know that a sub 1 is 5. That means a sub 0 equals 10/3 minus, nope, I lied. It means 5 minus 10/3. So I need to go backwards to find that term. So if I take 5 minus 10/3 and I find that common denominator, my a sub 0, which is my C, is going to be 15 minus 10 is going to be 5/3. So if I write my formula, a sub n is going to be dn plus c, which in this case, my d is 10/3, n is whatever term we're looking for, and my c value is 5/3. So if I look at that, that's kind of what is going on there. So you can think of this as a linear problem, so you can take and use the concept of slope to find the common difference, and then you can use the dn plus c. You just really have to remember that c is the 0th term. So even though we don't graph this, like we have my first, second, third, fourth, whatever, and if I count by 5s, we have 5, 10, 15. So my first term is 5. My fourth term is 15. So I know that I'm increasing. So if I want my 0th term is going to be somewhere down here. So I needed a number that's less than 5, so 1 2/3. So this basically represents 5/3 right here. It's not part of my function because I don't really start counting at 0. I start counting at 1, but that's where we start to keep the graph looking like it's supposed to look. Moving on. So arithmetic sequences using recursive formulas. Recursive formulas, the best way to think of them, recursive formulas are simply patterns. And it's almost what we've been doing. It's what you would do if you had no idea how to solve this problem and you were just asked to do it. You would use a pattern. So write the first 5 terms. If we have our first term is negative 4. So if I want to write my first 5 terms, 1, 2, 3, 4, 5. My first term is negative 4. And this says my next term. Okay, so this means I'm going to take my, if I plug in 1, this is going to be my second term equals my first term minus 3. So if I take my first term minus 3, I get negative 7. So then a sub 3 is going to be a sub 2 minus 3, and I'm going to subtract 7 again, or subtract 3 again. And then a sub 4 is a sub 3 minus 3, which is negative 13, and the pattern goes on. So negative 17. All right, so in example B, they went a little tricky on you, okay, and they gave you the sixth term. So if I think of this as a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6, this time they gave you that the sixth term was 1/2. Now, if I'm going bigger to the seventh term, I'm going to add 1/2. So if I'm going backwards to the previous term, I'm going to actually be subtracting 1/2, negative 1 and 1/2. So 0.5 minus 1.5 is going to give me negative 1. And if I keep subtracting 1.5, I'm going to get negative 2.5, negative 4, negative 5.5, and negative 7. So if you check this going the opposite way, if you took your first term, so your second term equals your first term plus 1.5. So when you're going forward, we're adding 1.5, but when we're going backwards, we're actually subtracting 1.5. All right, so now we're going to find the finite infinite series. And a finite just means we're going to take part of our list and we're going to sum it. You have a formula. If you noticed, we have S sub n, not A sub n, and it is n over 2 times A1 plus A sub n. You have to have two things to make this formula work. You have to have the number of terms, and you must have your first term, and you must have your last term in the list, which is A sub n. Okay, without those three things, this formula will not work. Sometimes they like to trick you and not give you A sub n, and you have to go find A sub n and substitute that back into the formula. All right, so if we have example 5, find the sum of 1, 2, 3, 4, 5, all the way up to 100. So if I look in this list, I have 100 terms. My first term is 1, and my last term is actually 100. So I'm going to find the sum of the first 100 numbers. I have 100 numbers. My first number is 1, and my last number is 100. So if I do the math, I get half of 100 times 101. So the sum of the first 100 numbers is 5,050. All right, if I keep going, it says find the 150th, and the word partial just means we cannot find the list of an infinite list, the sum of an infinite list. So we're going to take a list and we are going to just chunk it down and not find all the terms. So when I look at this list, if I go from 5 to 16, I'm adding 11. 16 to 27, I'm adding 11. 27 to 38, I'm adding 11. So I'm adding 11 each time, so that means my common difference is 11. I have my first term. My first term is 5. I have my n. I want the sum of the first 150 terms. But what I don't have is I don't have my last term. So this is really a two-step problem. I'm going to have to find that last term. So a sub 150, and if I think of dn plus c, so I'm going to take dn plus c, so my 150th term is my common difference, which we added 11. I want my 150th term, and c is going to be my first term minus 11, so c is negative 6. So if I take 11 times 150, I get 1,650 minus 6 equals 1,644. So now I have everything I need for the sum formula. So please make sure you use all the subscripts correctly. The sum of the first 150 terms is 150 over 2. Take your first term, add it to your last term, and we are good. So we're going to take 75 times 1649. And when you do that, the sum of the first 150 terms is going to be 123,675. Okay, and partial sum. This is called sigma notation. This is down here. This is what we call the lower bound. This is where we start. Up here, this is the maximum value of n, and this is your formula. So the sigma, the Greek letter sigma, just means sum. So I know that I'm looking for the sum of the first 50 terms. And when I do this, I am going to find my first term. So a sub 1 is going to be 1 plus 5, which is 6. And a sub 50 is going to be 50 plus 5, which is 55. So if I use my formula, I am going to take S sub n equals n over 2 times a1 plus an. And if you are one of those people that always gets confused, just write the formula down and then start plugging in the numbers that you have and find the ones that you need. So basically, this becomes a calculator problem at this point. 25 times 6 plus 55 is 61. And we get 1,000. The sum of the first 50 numbers is 1,525. All right, last problem. So if we want to go from the 51st term to the 100th term, we need to find the first term and the last term. So we're going to take the sum of 50 terms. So the 51st term to the 100th term is actually 50 terms because we're including the 51st term and we're including the 100th term. So the sum of 50 terms equals 50 over 2. And then remember, this is your first term. So for your first term, you're plugging in, so a sub 51 is our first term. And we're going to take 4 times 51. And if we do that, we get 204. And then my last term is my 100th term, and we're going to take 4 times 100, which is 400. And again, at this point, this becomes a calculator problem. 25 times 604, and we get 15,100. So the sum of the first 50 terms is 15,100. All right, so hopefully you learned some stuff about arithmetic sequences and series. The sequence is a list of numbers, and a series is the sum of the list. So, and remember, for arithmetic, we can only do partial sums because we cannot sum a list of numbers that continues to get bigger or continues to get smaller. All right, if you have any questions, I'll be more than happy to answer them in class next time I see you. Otherwise, have a wonderful day, and I will be seeing your beautiful faces soon. Bye-bye.